Right now, everyone is absolutely captivated by the sheer magic of models like GPT-4o and Claude 3.5. I mean, it's incredible stuff, right? But there is a much quieter, frankly, terrifying, invisible war happening just beneath the surface of all these magical tools we use every single day. In this explainer, we are going to dive deep into a major cybersecurity crisis. We're doing a full forensic breakdown of what actually happens when developers rush out generative AI applications, but completely forget the fundamental ABCs of network security. Let's get into it. To really wrap our heads around the massive scale of this crime scene, we just need to start with a number. 7,000. Yep. Elite cybersecurity researchers basically did a massive, exhaustive global sweep of the internet, and what they found was shocking. Over 7,000 enterprise servers hosting AI orchestration frameworks were just sitting there, completely exposed to the public internet. No robust authentication, just highly sensitive infrastructure with its doors wide open, practically begging to be exploited by automated scripts. And if you're wondering how fast the bad guys move when they find an open door, well, the forensic data is pretty grim. The median time elapsed between a developer initially configuring one of these servers and its total absolute compromise was less than 4 hours. Less than 4 hours. That is insanely fast. Hackers have built these ruthless, heavily automated syndicates to just scan the internet nonstop. The exact instant a vulnerability is detected, they strike. Exhibit A, the fatal upload flaw. So, how are attackers getting in so quickly? We have to look at their primary target, a framework called LangFlow. Developers absolutely love this tool because it had this gorgeous, intuitive graphical interface for building AI apps. But for convenience, it's shipped with an auto-login feature. Now, to be fair, this was only ever meant for isolated, air-gapped local testing. But, and you can probably guess where this is going, when developers haphazardly pushed those localized testing servers into live production environments, that little convenience became a fatal architectural compromise. And that oversight opened the door to CVE 2026-5027. The National Vulnerability Database registered this flaw with a critical severity score of 9.8 out of 10. 9.8. Basically, the core engineering team missed one vital step: cryptographically validating and sanitizing file name parameters during file uploads. They just left out that single crucial layer of security in their fast API endpoints. The result of that one missing line of code? A devastating path traversal vulnerability that led straight to complete, unmitigated remote code execution. Think about it like this. Under normal intended circumstances, you upload a file, say a simple PDF, and the Python code happily drops it right into the safe uploads folder. Harmless, right? But the malicious route? Because there were absolutely zero restrictive filters in the legacy source code, an attacker could just manipulate the file name. They'd inject a bunch of directory traversal characters, those little dots and slashes, straight into the request. Python's native path joining function didn't know any better. It blindly evaluated the input, allowed the attacker to escape the uploads folder entirely, and let them inject a highly destructive scheduled cron job directly into the operating system's root directory. Exhibit B inside a compromised server. So they've bypassed the upload validation and now they have full root privileges. Let's anchor this abstract technical exploit to some massive real-world financial stakes. We aren't just talking about average, cheap web hosting here. These compromised cloud servers are absolute beasts. Enterprises lease these incredibly high-performance machines to fine-tune proprietary AI models, and they are frequently running on dual NVIDIA H100 GPUs. For context, each one of those chips commands a market value of over $40,000. Once they're inside these ultra-expensive machines, the hackers don't just mess around. They execute a merciless, highly efficient three-phase playbook. Step 1. Rapid asset exfiltration. Grab everything of value immediately. Step 2. Cryptojacking zombie conversion. Basically turning that $40,000 piece of hardware into their own personal crypto mining slave. And step 3, lateral movement and pivoting. They use that compromised server as a trusted, fortified beachhead to sneak into internal corporate databases, completely bypassing any external firewalls. But honestly, step 1 is where the really lucrative devastation happens. The automated scripts aggressively hunt down a very specific hidden file in the project directory named .env. This file is a literal goldmine. We're talking OpenAI master keys, Pinecone vector database credentials, and proprietary PostgreSQL root passwords. Hackers instantly auction these stolen master keys off on the dark web. Next thing you know, your keys are being used to run massive phishing networks or generate SEO spam, and you wake up to tens of thousands of dollars in fraudulent invoice charges literally overnight. Now we get to Exhibit C, weaponizing natural language. This is where the crisis gets really insidious, because it moves way beyond the user interface and deep into the foundational infrastructure. Stuff like LangChain and LangGraph. You see, for autonomous AI agents to actually hold continuous, coherent conversations with us, they need a memory management module. They have to persist conversational history. But that specific architectural requirement has created a uniquely terrifying new attack vector. Just look at this meticulously engineered prompt injection payload. In the old days of traditional hacking, you'd have to forcefully cram SQL commands into an unvalidated search bar. Not anymore. Now the attacker is using polite, conversational English as a Trojan horse. If a user types this prompt into a corporate banking bot, and the AI's memory module blindly saves that natural language input to the back-end database without sanitizing it first, bam! It forcefully transmits a bespoke SQL command. You could irrevocably delete an entire customer database just because your AI read a sentence. And that brings us directly to Exhibit D, the Great Firewall Blindness. The absolute core systemic failure of our current enterprise security is this: a legacy firewall simply cannot stop a sentence. Our multi-billion-dollar defensive arsenals were brilliantly engineered for the predictable, rigid web of yesterday. But for the non-deterministic, conversational AI web of today, they are completely useless. The traditional security perimeter has essentially evaporated right before our eyes. The statistics from recent threat landscape reports are pretty staggering, honestly. Over 70% of commercial, enterprise-grade web application firewalls completely fail to detect or mitigate sophisticated prompt injections. Why? Because the malicious payload perfectly mimics benign human language. And shockingly, 45% of heavily funded startups building on frameworks like LangChain were found to be storing highly sensitive API keys in absolute plain text. Nearly half of them. They are effectively operating completely blind. Security analysts actually have a name for this. They call it traffic blindness. When an autonomous rogue AI agent systematically hemorrhages your classified proprietary data, it doesn't even trigger a single alarm on a Security Operations Center dashboard. And the reason is crazy. The exfiltrated data is perfectly encapsulated inside standard, valid JSON, and it's transmitted across highly secured TLS connections. So, to a traditional legacy intrusion detection system, this massive data theft just looks like standard, authorized business logic having a normal chat with opening off. Because of this traffic blindness, we're seeing some terrifying metrics. 212 days. That is currently the abysmal average dwell time, the duration a hacker remains completely undetected inside a compromised AI infrastructure. 212 days. To put that into perspective for you, advancements in endpoint detection had successfully reduced that number for traditional servers down to fewer than 40 days. Right now, our AI servers are essentially operating as completely unmonitored black boxes. So how on earth do we fix this? Exhibit E. Securing the AI frontier. First things first, relying on reactive software patching is an antiquated strategy. Yes, the open source community patched Langflow quickly, but those thousands of unpatched enterprise servers are still out there, serving as the lifeblood of massive botnets. To genuinely secure this new frontier, organizations must orchestrate a total paradigm shift. We have to completely abandon the perimeter-based security model and forcefully transition to an uncompromising zero-trust architecture. Think of this as your DevSecOps cheat sheet for locking down AI infrastructure layer by layer. For access control, to stop login bypasses, you must disable config.yaml auto-login immediately, enforce MFA, and use a reverse proxy. For secrets management, eradicate those local .env files, mandate an enterprise tool like HashiCorp Vault, and auto-rotate your keys. At the orchestration layer, deploy dedicated LMM filtering firewalls like LMM Guard as a reverse proxy to actively intercept those malicious linguistic patterns. And for your OS and infrastructure, run Docker with the -read-only flag to forcefully block any paths reversal executions. Trust absolutely nothing. Now, what if you're running a massive legacy architecture and you simply cannot halt production today to patch core foundational frameworks? Okay, here is an actionable, temporary, technical tourniquet.
You need to deploy aggressive filtering rules right now. Target your Nginx Langflow upload endpoints, rigorously validate the query parameters, and instantly terminate any connection that contains those // directory traversal patterns. Just return a straight 403 forbidden error. It's temporary, but you have to stop the bleeding at the edge. The reality is secure by design is no longer a luxury. It is the absolute baseline. The evolution of artificial intelligence simply has to be inextricably linked to the rigorous evolution of AI security. If we keep treating these frameworks like magical black boxes while totally neglecting fundamental security protocols, the cost won't just be massive cloud billing, it's going to be the total destruction of customer trust, which leaves us with this final critical question to chew on. If we don't change our architecture today, will our most intelligent tools simply become the most devastating weapons wielded against us?